Okay, look, thanks for attending. Today I'm just going to give you a brief overview of recent work that myself and colleagues in Juna have been doing to try and develop a method of using remote sensing data to monitor the soil erosion risk across the agricultural lands of South Australia. Now, just a bit of context. A bit over 10 million hectares in South Australia is used for farming, for cropping and grazing, agricultural systems, and significant areas of that land, due to the nature of the soil types, rainfall and topography, are inherently susceptible to erosion once cleared of the vegetative cover, or when they're cultivated and therefore physically disturbed as well. And going back to 1999, the Department of Primary Industries established a program of monitoring the soil erosion risk across the agricultural areas of the state using a roadside survey method. Now, we have actually still been able to continue that through the various incarnations of the agencies, and what this involves is visual observation from the roadside of what's in the paddocks, particularly looking at the amount of surface cover that's on the ground, where we use a 1 to 8 scale ranging from full cover down to 8 being bare soil. We also assess the physical disturbance of the soil at that time, and we also take into account at all the sites they're characterised for the inherent susceptibility to wind or water erosion based on the local topography, soil type and rainfall, those sort of things, both for wind erosion susceptibility and water erosion susceptibility. And we do those surveys 4 times each year at the same time slot, which correspond to particular strategic stages of the normal annual crop growth and senescence cycle, and the cropping preparation and harvesting cycle of how that affects the amount of surface cover and exposure to soil erosion. The results, which is the tail end of the graph that Tim put up a little earlier, from those surveys have shown that there's definitely been an increasing proportion of land protected through more of each cropping season. And when we express that data in terms of as an annual index of the cumulative number of days that the soil is adequately protected from erosion, we see that line is clearly going up, and while it may be starting to level off, it's certainly showing a substantial improvement, and that, of course, we know has corresponded with the uptake of no-till and stubble retention practices, which have been particularly prevalent over the last 15 years, as well as improved grazing management and so on. Okay, that's all well and good, but in recent years, due to budget cuts, we've had to re-evaluate that program and had to cut back the amount of land that we're surveying. But at the same time, there have been a number of developments in remote sensing satellite technology that potentially have the potential to substitute or replace these field surveys to monitor erosion risk in the agricultural areas. So we looked at a number of things. Going back a few years, we started looking at MODIS data where we engaged Ken Clark from the University of Adelaide at the Waite to try and evaluate whether MODIS data could be used to monitor ground cover percentage as a surrogate of erosion risk. So that work was promising, but we more recently moved to looking at a product that came out of CSIRO from Gershman and his colleagues, which was called a fractional cover index, or MODIS fractional cover. And this product is based on an analysis of MODIS data at 3 different wave bands, so it can produce an estimate of the relative proportions of bare soil, photosynthetically active vegetation and dry vegetation, so that can potentially give us that measure of percent cover versus percent bare soil as a surrogate measure to estimate erosion risk. So we started looking at how that data would compare to our field survey data. And we found that there was not a particularly good match with just the basic processed data that is freely available and produced as a monthly product. There's a number of reasons behind that, so we had to sort of tackle those to develop a calibration model. Trevor Hobbs has really been the brains behind all of this modelling. So we basically had to use the field survey cover rating data since 2006, when we first geolocated the field survey sites, to use that to recalibrate the MODIS data according to the local conditions. So we had to account for issues that affect the MODIS reflectance data, such as soil colour, soil type, and soil moisture levels, but also the season and the sun angle. And Trevor was also able to incorporate disaggregate modelling to, I guess, be able to improve the resolution of the MODIS data, which is at a 500 metre pixel, is relatively coarse. So just a quick visual of the sort of thing that was built into the model. The bottom left shows the relatively coarse MODIS product results. And the top right is basically just an illustration of this disaggregation model, which takes into account long-term existing native vegetation stands, but also predicts where plant growth is more or less likely to occur in the landscape due to local topographic highs and lows and that sort of thing. So the bottom right is an example of the result, which, when the modelling showed it considerably improved the resolution and accuracy and agreement of the model against the field survey data. So the method involved using the models to estimate the MODIS cover rating to match the field survey cover rating at a down to that 90 metre scale for the bare, green and dry MODIS data, which factored in some digital soil data such as soil texture and soil pH to help improve the model. We had to develop a separate model calibration for each of the survey months, October, March, May and June. And we also found we had to build in a separate model for when we're talking about areas naturally prone to wind erosion versus those areas prone to water erosion, and map those as part of the exercise, because of the fact that in the field survey method, we score the cover rating slightly differently in the wind erosion prone areas to the water erosion prone areas due to the fact that the nature and type of cover that protects land from wind erosion is more related to the height and the vertical density of the cover, whereas in water erosion it's more the actual percentage of ground cover which protects against raindrop and rill erosion. So having done that, we found that the soil types and seasonal time significantly influence the relationship between the field survey cover rating and the MODIS predicted cover rating. So we were able to calculate MODIS-based cover ratings for all of the survey periods, and including a back calculation pre-2006 by reprojecting the geolocated sites. And so with all that, we're now able to generate new wind and water erosion risk maps for those 4 survey times each year, as well as annual maps, which I'll show you shortly, as well as the corresponding data, which we can express or calculate by region, by state, or by sub-region, depending on what the reporting requirement might be. Okay, so the time series analysis ratings are used to evaluate the number of days per year by region or sub-region where the soils are exposed or protected from erosion. And we found overall, or after several iterations of the modelling, that the satellite predicted data ended up giving a reasonable agreement with the field survey data. To show you, the red is the field survey generated data that I showed you earlier, and the blue is the MODIS modelled cover-based estimate of erosion risk or erosion protection over that time period. And you can see that the agreement is reasonably good. The trend is the same, but not quite as strong, the upward trend in erosion protection. But we achieved an 80% match between the modelled and the field survey data, and we're fairly pleased with that. And again, if we can slightly improve the agreement if we take out the first few years of the field survey data, because there may well have been some inaccuracies in the early years of the field surveying. So just show you examples of some of the final products. So this is the statewide MODIS generated cover rating based estimate of erosion risk, ranging from 1, which is highly protected, through to 8, which is basically bare soil. In October, where there's normally maximum cover and maximum protection, through to March, when there's normally some degree of deterioration of stubbles and pastures due to grazing and natural breakdown, through to May, when there's normally round about the break of the season or thereabouts, start of crop sowing, start of pasture germination, starting to get some areas coming into the marginal or at risk. And June in 2015, probably a lot of the land just been sown, some of that being cultivated, so you can see sort of the patches and areas where we can pick up the land at risk versus protected. We can present the maps with simplified legend categories like that, however we might want to do. This is the map showing the cumulative days of protection or at risk throughout the 12-month period, showing that the vast majority of the state, according to this data, is well protected and at risk only for less than 15 days of the year, which is a very good result due to our modern farming practices. We can zoom into sub-regional areas to look down a bit more closely, but the purpose of this data analysis is not to get down to a paddock or even a property scale, really. It's for regional and statewide monitoring, and due to errors and inaccuracies with this sort of resolution of data, any hotspots or areas that might present issues at this scale should be obviously investigated on the ground by the regional NRMs accordingly. And we can also look at areas under native vegetation and see like a fire scar there above Barmera. This sort of technology can certainly look at those areas as well. So in conclusion, I guess we're confident now we've got something that we can use to monitor and report on erosion protection in agricultural areas as an alternative to the field surveying, and so that's where we're going to now. So thanks very much.
Thank you, Giles. Any time for questions? Maggie.
Giles, good to hear how the whole program is developed. That's really good news. In the fractional cover product, are you using the soil component or the vegetation component for your analysis?
We've actually ended up using all 3 bands to incorporate them into the model. We found that was slightly better than just using the bare soil alone. Yeah.
Have you looked at all in extending this technique to the north, to the pastoral lands and the degradation?
Our program is just looking at their agricultural zone, but there is in fact a national program out of ABARES that have developed or utilised this MODIS fractional cover product from CSIRO for a national scale monitoring of ground cover, which is more attuned to the rangelands across the country. So that is being done at a national scale. I'm not quite sure what our South Australian pastoral land side of things is up to, but I'm sure they would be developing some sort of remote sensing method similarly, yes.
Yeah, Giles, what's the plan with the field-based side of this monitoring?
Well, look, at this time, James, we've still we're doing reduced surveying, which is about half of what we used to do across the 4 agricultural cropping regions. We're hoping to sort of just continue that on in parallel, in tandem with the remote sensing work for at least another couple of years. Beyond that, we're not quite sure, but that's what we're hoping at this stage. But I think we would still be needing to do some selective ground truthing on an ongoing basis for whatever to just keep the motors ground truthed. Yeah.
One more quick one. Just another one. Is there any plans, or will this data become publicly available? So, you know, the maps of the erosion loss?
Yes, look, we hope we will get this up. We'll have products available up on the web in time for the regions, junior or the public to use and access. And I might add too that the development work for this modelling, we are intending to write up and publish that as well. Yeah.
Thank you. So we've got break for lunch now, and talks resuming at 1:30. But let's thank Giles and all the